I'm Takumi Nomura from Shibata Institute of Technology. Our research topic is driver drowsiness detection. Recently, traffic accident caused by driver unexpected falling asleep have become a serious problem. Therefore, a method to detect drowsiness before an accident occurs is required. However, it is not easy to collect data on accident. In this study, we proposed a method using TSNE and the effect were investigated. TSNE is a dimensionality reduction algorithm that performs dimensionality reduction while preserving the distance relationship as much as possible. Look at figure 1. The future vector obtained from multimodal bias signal were mapped to two dimensions by TSNE. This is an example of the temporal change of the trajectory. It was found that the mapped point moved continually over time on two-dimensional space and then often transition to a distance point. This continued movement is called mapped point path. Since TSNE performs dimensionality reduction while maintaining the distance relation, the distance relation is preserved even after mapping. Therefore, the closeness of the mapped point means the closeness of the original multimodal bias signal. Therefore, it was hypothesized that mapped point paths corresponded to the same mental state of the subject, and the transition from one mapped point path to another corresponded to the transition from the mental state. The experiment was conducted on the drive simulator, and features such as alpha power were extracted. After that, SVM was trained to consider that mapped point paths containing collision and cause-out event as danger, and the other paths as safe. After randomly selecting and training 18,000 times, the distribution of accuracy was as shown in figure 3. Most of the distribution were in the 50%, and the rest were widely distributed over the 90%. There are some models that achieve as high as 90% accuracy. By extracting the model with high accuracy, we can expect further improvement in accuracy. This study shows the TSNE method may be effective in detecting driver drowsiness. That brings me to the end of my presentation. Thanks for your attention.